calculate that C of n? Well, this is where differentiation comes in. This particular series that you see here is what we call a Taylor series. Now, I'm not going to elaborate on that because we're not going to be dealing with Taylor series. We're going to be dealing with a particular form of Taylor series, and that's when the A value of the Taylor series is equal to 0. So this is our closed form, and this is our expanded form. So that simply represents f of x is equal to f of a. Now look very carefully, because this is what we are going to be doing. The first derivative at the point a times x minus a. The second derivative over 2 factorial times x minus a squared. This is a formula for the Taylor series. But we're not going to use that formula. We're going to use the formula when a is equal to 0. So substituting a equal to 0, I get a formula for the terms of a Maclaurin series. And this is the formula that you are going to use and that you should know. And how is it? You can simply memorize it. So substituting a equal to 0, I get the first derivative at 0. And if this a is equal to 0, then I'll only get x. The next term, the second derivative at 0 over 2 factorial x squared. And you can see the pattern. Third derivative at 0, x cubed. So this is going to, oh, okay, can just correct that. This is going to be the aim in this lesson, to find the series of a particular function by repeated differentiation. So let's get right to it. Example 1. Find the Maclaurin series for the function f of x is equal to sine of x. So going back to our formula, I need to find f at 0, first derivative at 0, second derivative at 0, then substitute into this formula. So I'm going to lay it out so that you can understand and see. You do not need to follow the same pattern, but in my lecturing, I will rather present it in a form which I feel may be easier to remember. So what I do is I put the function on the left, f of x, and that of course is f of x is equal to sine of x. Then next to that, I must substitute 0 into that function, sine 0, that gives you 0. Then below that, I start finding the derivative. First derivative, what's the first derivative? Cos of x. Then I substitute 0 into the first derivative. Cos of 0 gives you 1. I continue the second derivative, minus sine of x, and substitute 0, minus sine 0, 0, and continue. So how you set this out, for example, you can say, okay, I'm just going to find the third derivative. What's the third derivative? Minus cos of x. Then I'm going to find the fourth derivative, minus sine of x. That's going to give me plus x. Then I'm going to find the fifth derivative, which is cos x. And then afterwards, I'll substitute 0. Well, you can follow your own sort of pattern. So that becomes minus cos 0. That gives me minus 1. The fourth derivative at 0. Sine 0. That gives you 0. The fifth derivative, cos of 0, and that gives you 1. Okay, so here I found 5 derivatives. Now I substitute into the Maclaurin formula. So let me write the Maclaurin formula once again. F of x, what's the first term? F at 0. Second term, first derivative at 0 times x. Next term, second derivative at 0 over 2 factorial x squared. Third derivative at 0, 3 factorial x cubed. Well, there's the pattern. Fourth derivative, 0, 4 factorial x to the power 4 plus, and so on. So for sine of x, let's see what happens. What's f at 0? 0. What's the first derivative at 0? 1 times x. What's the second derivative at 0? Well, that's just 0. So we won't bother with the others. What's the third derivative at 0? Minus 1 over 3 factorial x cubed. Fourth derivative, 0. Fifth derivative, 1 over 5 factorial x to the power 5 plus, and there, simplify that, get x as the first term minus 1 over 3 factorial x cubed plus 1 over 5 factorial x to the power 5. And there are the first 3 terms of the Maclaurin series of sine of x. Now in this one we see a pattern. That's 1 times x minus, so that's a plus, minus, so it's alternating. The next term will be minus. And then notice the indices are odd. So it's 1, 3, 5, and the factorial is also odd. So this will be, what is the next term? 1 over 7 factorial x to the power 7. What would the next term be? That's right. And so on. And there is a series expansion for sine of x. Let's go to the next example. Find the first. Now I can, so you must have been wondering, when do we stop our differentiation? Where? It's going to depend on the question and also the problem itself. So yeah, we want to find the first 4 non-zero terms of the Maclaurin series for ln of 1 plus x. Okay. So what is this? The ln of 1 plus x. I'm going to make f of x is equal to the ln of 1 plus x. F at 0, the ln 1 plus 0. The ln of 1 is equal to 0. Now I find the derivative. I just want to quickly check something here. Right, with that, and let's go. Okay, let's continue. F of x is equal to ln of 1 plus x. If at 0, ln of 1 plus 0, ln of 1 equal to 0. What do I do next? I find the derivative. First derivative. Do you remember the derivative of ln? That's right. It's 1 over 1 plus x. Okay, let's continue. Sorry, I needed to double check. Now, let's start again. Find the first 4 non-zero terms of the Maclaurin series for ln of 1 plus x. So f of x is equal to ln of 1 plus x. First derivative 1 over 1 plus x. Yeah, that's going to be easy. First derivative at 0. Wherever I see that, I can work that out. 1 over 1 plus 1, that gives me 1. But now I need to find the second derivative. Now look at that. The second derivative of 1 over 1 plus x. Do I use a quotient rule? Then I must use the third derivative and the fourth derivative. Can we simplify this? Well, in this case I can. Because the numerator is a constant 1, I can take this term 1 plus x to the top and write it as my 1 plus x to the minus 1. Then I can use my chain rule. Now, notice differentiation starts playing a major part. So know your differentiation rules, revise your differentiation. Otherwise, you're going to have a major problem with series. In fact, for the rest of the course as well. Differentiation plays an extremely important role. Now, in this case, I just want to use possibly another color. Let's use black. I'm going to use the chain rule. First, I'm going to do minus 1, and then 1 plus x. So multiplying through and using the chain rule, minus 1 times 1 gives me minus 1, 1 plus x, and remember the rule, subtract 1 in the index, so that becomes minus 2, and the derivative of 1 plus x is simply 1. So here I get negative 1 plus x to the power minus 2. Now I must substitute 0 into there, substitute 0, 1 plus 0 gives you 1 to the minus 2, which is 1, that gives me minus 1. And then I'm going to continue. My third derivative, again, minus 2 times minus 1, so there you go. The normal chain rule, the normal power rule, derivative of a power rule. Minus 2 times minus 1, plus 2, subtract 1 from the index, 1 plus x to the minus 3, find the derivative at 0, that gives you 2. Fourth derivative, minus 3 times 2, negative 6, times 1 plus x, subtract 1, minus 4. My fourth derivative at 0 gives you minus 6. Fifth derivative, minus 4 times minus 6, 24, times 1 plus x to the power minus 5. My fifth derivative at 0, 24. Now, do I have 4 non-zero terms? Yes, the first term is 0. In fact, I have more. I've got 1, 2, 3, 4, 5. Now I substitute into the Maclaurin series formula for f of x, and I'm going to repeat that. What is that formula? F at 0, first derivative at 0, plus second derivative at 0 over 2 factorial x squared, third at 0, 3 factorial x cubed, and so on. Therefore, ln of 1 plus x is equal to, what's f at 0? That's 0. What is the first derivative? That is 1 times x. What's my second derivative? Minus 1 over 2 factorial x squared Next derivative, 2 over 3 factorial x cubed minus 6 over, yes, 4 factorial x to the power 4. I have 1, 2, 3, 4 non-zero terms. Don't need to write on the next one. And then simplify, I get x minus a half x squared plus 1 over 3 x cubed minus 1 over 4 x to the power 4. There is your series expansion for ln of x. Now, just as an aside here, and how do I simplify 2 over 3 factorial? Do you recall? Well, you have a calculator, you can do that. That will be 2, what's 3 factorial? 3 times 2 times 1. 2's cancel. What's my answer? 1 over 3. What about 6 over 4 factorial? That would be 6 divided by 4 times 3 times 2 times 1. Simplify and you get 1 over 4. Okay, I'm going to stop the first one there. It hasn't completed all the examples. I'll continue that in the next lesson. Stop this recording.